Welcome back. Experiment number 6, titration squared, a diprotic acid. Okay, so essentially titrating a diprotic acid is very similar to a monoprotic acid. HCl was the monoprotic acid that we worked with last week, whereas H2SO4 is the diprotic acid that we're going to work with this week. Okay, now we're going to be using the exact same sodium hydroxide as a strong base to react with that H2SO4. But what you need to know about this is, well, how does H2SO4 differ from HCl? Well, I mean, the obvious is that you've got SO4 compared to Cl, but then you've got one HCl compared, or one H compared to 2H. Okay, so the hallmark, or the central part of this experiment, from a technical standpoint, it's the same almost. From a practical standpoint, in doing this procedure, it's going to vary a little bit. We have sodium hydroxide that we're going to react with H2SO4. That's sulfuric acid. Sulfuric acid is made up of 2 hydrogen ions and a sulfate ion. You're going to produce with that Na2SO4 and H2O. Just like last week, we had aqueous, 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 and a liquid. What you need to know about this is, well, you're going to be given the concentration of sodium hydroxide. You're going to not know the concentration of sulfuric acid. So you will need to use the volume of sodium hydroxide and the concentration to figure out, based on the 25 milliliters or so that you use, the specific amount of H2SO4, what is the concentration of that H2SO4 solution. You'll do this a total of 3 times. Like last week, the first time you do it will make the second and third times easier to do. I hope this is helpful. If you're unsure about any of the calculations related to titrations in general, well, you can go back and watch the previous video. But also, what you really need to be concerned with is, what's the molar ratio of a balanced chemical reaction? Of NaOH plus H2SO4. You know, I'm going to go ahead and just solve this one for you. So I'll show you the balanced chemical reaction of what we're looking at. We've got, well, we've got 1 sulfate. Oh, but look at this. Sodium, and then there's 2 sodiums. So we got to put a 2 coefficient in front of that sodium hydroxide. Okay, so that will bring us to our 2 sodiums. So those are going to be balanced. Sulfate is balanced. What about our hydrogens? We've got 2 hydrogens here and 2 oxygens here. We've got 2 hydrogens here. So we've got a grand total of 4 hydrogens on the left-hand side of the reaction in my reactants. And I've got only 2 on the product side. But if I put a 2 coefficient in front of my water, I'm balanced. Okay, so what this tells us is that we have 2 moles of sodium hydroxide to react with 1 mole of H2SO4. So what that means is, if you need 27 moles of NaOH for the reaction to fully neutralize, that means that you need 13.5 moles of H2SO4. Or one way that you could look at this is that 27 moles of sodium hydroxide perfectly reacts with 13.5 moles of H2SO4. All right, well, I hope this is helpful. Have a good one.